Hi, this is Team 14 and my name is Giridhar Peddabutaigari. In this video, we would like to present the demo of our capstone project Pivi. Pivi is a visual programming plugin for Eclipse. The primary goal of this project is to help students understand and visualize the programming constructs in Java in a better way. In order to do this, we provide an easy and interactive user interface to construct the visual model of the program. The plugin typically has two major parts. The first major part is the palette, which is placed at the right end of the application. Palette has all the nodes and the valid connections that can be used in a visual model. The other important part in the application is the chart. The chart is the area where a user can drag and drop the nodes present in the palette and add the connections between these nodes. Each node is an icon in the UI that symbolizes a programming construct. A connection is a valid link between two nodes that symbolizes the flow of the program. Once the visual model is ready, there is a button called Generate Code in the application. User can click on this button to generate the code that the diagram represents. To build this application, we used few frameworks present in the Eclipse marketplace. One is the graphic modeling framework, which encompasses both EMF and then GF. We used EMF to build the core model which is present underneath the application. We used GEF to build the user interfaces for all the programming constructs, and then we mapped both EMF and GEF in a seamless way. So we have several icons present in our application. The one major icon is the start icon, which represents the main method inside a class. There is an instruction icon that represents a programming instruction that can be entered as a parameter to the icon. There are two icons, one is method start and the other is the method end, which symbolize the start of a method and the end of a method. We have a conditional statement which is if statement. There is a if start icon and then an if end icon. If start icon symbolizes the start of an if statement which takes a condition as a parameter to decide whether to go with the if or the else part, and if end symbolizes the end of the if block. We also have a loop statement which is while. The start of the loop statement is while start icon and then the end of the loop statement is the while end icon. Now let us take a closer look into the demo of our project.
Hi, I'm Srikiran and let us now look at the PV demo application. So let me first go into the Eclipse IDE and create a new project. So it is a general project and let us give a name for it, say PV demo, and then let's go and finish. So and then now after we install our Eclipse Pivi plugin, we will be able to see this Pivi diagram here. So this once the Eclipse plugin has been installed for Pivi plugin, then we'll be able to see that, and then you can create this Pivi diagram inside of our project and then click finish. So this will launch an canvas and palette which will consist of nodes and connections associated with it. So this will have a PV XML file and a PV diagram file. The PV diagram file is the graphical interface part. So now let us start with a small example of if else. So first we'll have a start of the program. So this is the start, and then we'll have an instruction where we can initialize something, and then we'll go ahead and put a if start node. So this is the if start node where we have to give the condition uh, for the if statement, and then if the condition is successful, we have to write something inside this, which I will be explaining later. And if the condition is false, we'll have to put something inside the else part, and then this will denote the end of the if statement block. So this complete block is a if block, and this is something which comes before the if statement, so something like initializing variables or anything we can do, and this is the main start of the program. So now let us go and connect the nodes. So this one, the start will be connected to the instruction node, and then moving forward we'll connect the instruction to the if start, and then followed by the others series of connections like So if you see the success case will be going to the above instruction, and the failure case will be going into the below instruction, and then finally we'll merge both of them, and then we'll close the if statement. So this is how the program flow will occur, and since there is nothing after the if end, there will be no set of instructions after this. So if you double click on the instruction node, you can write anything. Like for example, I am initializing a variable called a and setting its value to 5, and then if I double click on the if condition, we can actually give the condition. So a percentile 2 is equal to 0. So we are checking if a number is even or not. Then if you click on finish, the value, the statement which we have written would be saved, and then if the condition is successful, we'll actually print say the number is even. Out dot even. So similarly, we'll do in case of false condition, we'll say that it is odd. So I have just copy pasted the data and then finish. So if you can see, initially we are making int a is equal to 5, and then we are checking a condition, and then if it is success, we'll print it as even, otherwise we'll print it as odd. So this is the graphical visualization of the code. Now if you can see a button on top of this generate code, it will actually generate a it will actually generate a Java file for us. So this is the Java file that got generated out of this diagram. So if you can open and see that, we'll be able to see whatever we have written. So if we compare that, we can see that this is the start. So there is a main over here, which is the start of the program, and then this is the first instruction, a is equal to 5. So that is what has come here, and then if condition, which is a percentile 2, is being checked here, and then if it is a success, this system.out.println is coming out here, and this similarly we'll get the else condition. So and then the end of the program. So this is how we can actually visualize our coding perspective in terms of a diagram, and then also compare it with the code that has been generated. So this is a single step process, and then we'll be able to understand how a if works in such a scenario. So this is the first demo part. Next we'll be explaining while and how it works. Thank you.
Hi, I'm Nitya Kogaleru, and now I'm going to demonstrate an example for the while loop construct. So this symbol is the instruction statement that is used to initialize the variables. Here we are initializing the temp variable, as you can see. This symbol marks the start of the while loop. Here we give the conditions that are necessary for the while loop to be executed. This is the block that gets executed inside the while loop. Here in this instruction block, we are printing the code that is used to execute the numbers, or that is used to print the numbers from 5 to 0. And this block is used to mark the end of the while loop. So when I click on the generate code button, the code that is corresponding to this diagram gets generated in Java. So now I'm going to demonstrate that. So I clicked on the generate code button, and when I refresh here, I'm going to get a solution.java file that indicates that shows the code corresponding to the diagram. So this is the code that is in Java, which corresponds to the diagram. And now in the next example, we'll look into methods, an example that shows method, which is going to be explained by my fellow teammate.
Hi, this is Pujita Kara. I will demonstrate an example for method definition and declarations. This node denotes the start of the program. This is an instruction node we will use to call the method. This entire part is the method definition. This node is the method start. We can give the method name in here. I just named it as hello world method. So this is the method body. As an example, I just printed hello world. You can give any other instructions in here. This node denotes the end of the method. So this is the instruction node which we are using to call the method. So from main, we are calling the method. This will execute the method in main. So let us generate the code for this example. So this is the generated code. As you can see, this is the method definition where I'm just, and inside the body, I'm just printing out hello world. Inside main, we are calling this method.
Hi, I'm Sneha Shendware from the group 14, and I will be talking about the future work and the conclusion of the PV project. Uh, the future work of this project is to scale it for the concurrent programming so that we can have the visual basis for the threads. The student can visualize the threads. It can be extended for the distributed computing so that the performance of this project can be extended. The code we run, it can be run on the multiple servers. This project can be standardized to be placed in the Eclipse marketplace so that Eclipse community people will use it. So the conclusion is, like, this project is very much easy and interactive plugin. It can help you develop the less error prone code so that you will not make mistake while writing the code. It will help the student to understand the parallel programming and distributed programmings, and this code can be used to write the most efficient code if followed the best practices. Thank you.